Hello, everyone. My name is Balakshin, and today we're going to talk about such things as gameplay components and access them in a proper way. Small disclaimer: there will be really a lot of code snippets in this presentation, so I hope you're familiar with C++ on some kind of level. Few UML diagrams, so I hope you're kind of familiar with object-oriented programming, and I hope it won't make you sleep, actually. Okay, couple of words about me. So Michael already told everything. I'm in game development. I'm working in Sperasoft, Keyword Studio. I'm senior software engineer. In game development started in 2014. Before that, there were several years of, let's say, enterprise programming. And for the last couple of years, I have been making significant contribution to post-launch seasonal updates of Rainbow Six Siege. Sorry, this is the only thing that I'm allowed to tell. Originally as a gameplay programmer, and then as a gameplay lead. Couple notes about our company. Sperasoft is a worldwide known contributor to AAA game development, providing various service lines to such first-party companies as Ubisoft, Electronic Arts, Riot Games, Wargaming even, NetherRealms, and so on, so on, and so on. We exist from 2004, and for these 14 years, we've contributed to more than 60 games. Most of them are AAA titles, such as Mass Effect Andromeda, just Mass Effect series, Quantum Break, EA Sports games, FIFA, NHL, and of course, Rainbow Six Siege, and latest Assassin's Creed Origins and Odyssey. So if you're interested, check our site. Last year, we became a part of a Keyword Studio global holding of making also contributions to and also service lines to worldwide game development industry. So I think that there will be a lot of interesting projects. So check the updates. Okay. Throughout the years, there have been several approaches, various approaches of representing game objects inside game, of what actually game is. Starting from arcade machines and hardwiring this stuff. Then closer when you were able to download and make any software, it still was very bounded to hardware. It was right inside update loop and pretty simple and effective. But the more came technologies evolution and more they became complex, there were several approaches of representing and abstracting gameplay entities from other systems such as animation system, render system, and so on, so on, so on, and just to find appropriate way and comfortable way just to interact with all that we have as game engines. I would pick up 3 ones. So our lovely past, I hope, but unfortunately it's still supported by some game engines, including as Unreal Engine, is object-oriented design. Then our present component-based design and data-oriented design, which is kind of promoted right now by such companies as Unity, Amazon, and even by Blizzard. They might overwatch for this. Pure object-oriented approach. We try to benefit from inheritance property, so where we can extend properties of such objects by adding children. And as a very raw example would be following. So let's imagine that we have some class which is called entity, and it means that it's any object, game object that exists in the world. It shouldn't be drawn, shouldn't be displayed. It should have some children that have only this basic property as transform and have a couple of virtual methods as update and begin play. Then we have drawable entity which we need to draw to represent a visual, maybe such as some kind of skybox or something that don't have any kind of collision. Then we need physical entity for detection collisions. So right now, by creating children from this abstraction, we would be able to add some kind of object as walls, doors, tree, and other obstacles. And for example, if you want to control a game object, so we want to represent player, vehicle, or turret. We create controllable entity with input.4. This approach have a lot of complexities. First of all, the more you develop, the more this inheritance streams becomes larger. And eventually it becomes really hard to control it, to maintain it, to fix it. Also, there's a really big problem when you need to mix some kind of strange behavior. What if you want to have physical entity which is not drawable at all? Some example of collision zone. So should create one more children, or maybe just add modifications in the parent. Lots of rumors. That's why wise people thought about it and say, okay, let's benefit from composition over inheritance and created component-based approach. I think the first time it was introduced was 1999 Dungeon Siege. I heard that it was also used by Thief Dark Project. Well, you can check up Wikipedia if you're interested in. So the idea is following, that instead of keeping everything in entity and its children, we create some base class which encapsulates state and behavior of particular functionality. And by collection of these classes, we'll define our state and behavior of our required game object. And the UML diagram would look something like this. You would have this entity class with collection of components with some base methods which also invoke such methods into components, and various tree of these components. From base component, if you need to display object, you create mesh component, material component. If you want to add collision, you create collision physics component tree, base physics, then rigid body, wheel, cloth, and so on, so on. Then controller and AI component for any entities. This approach is used, I guess, by almost every game studio right at the moment, especially for their legacy titles. And if you're familiar with Unity on Unreal Engine, you can also use it. You already know what I'm talking about. And in this case, our game objects would look like this. So tree, we have physics, mesh, and material. For character, we just add controller. For enemy, instead of controller, we add AI component. For vehicle, well, okay, let's add the controller and wheel component additional, whatever it is. As I mentioned, it's kind of widespread, not only in affordable and public engines, but also in proprietary ones. And there were really a lot of mistakes and problems. It's really a lot of rumors on should we follow this conception or not, because it still uses inheritance models and all problems related with that. That's why, as I mentioned, most studios are trying to invest in such thing as data-oriented design or entity component system. The idea is that in component, you store only state. You have just some kind of service model, but you don't define behavior by components. Behavior is specified by systems which are running a particular set of components by just giving access to index or description and writing the result into one or few components. If you're very interested in a lot of Unity talks about it. On 2016, there was a really cool presentation in GDC by Blizzard guys. And yeah, this thing helps to do really a lot of interesting stuff. First of all, it's very cool aligned with modern hardware architecture. You almost won't have cache misses and other crap if you do it in a proper way. Second, it could be really easily extended to multi-threaded environment by, for example, just assuming that you have system have only one output. It can write to one component, and you just create and you duplicate set of properties by adding initial ones and then the final. So beginner frame set and final frame set. And yeah, you'll have parallelism out of the box. It really allows to do such, in multiplayer games, it allows to have such thing out of the box as replication and replays. And usually in multiplayer games, it's such a huge pain in the ass, guys. So please believe me. Yeah, so profit. The problem is that it's really new. And while working in game development industry, especially with AAA companies which are making not a single title, not the initial one from scratch, but a series of titles, and which are based on their technology stack and their approach, which could take roots in the early 2000s or even 90s, it's very hard and complicated to refactor it, to organize it, to change it. There's also, well, I guess, a really interesting talk on Unite by Aras Prashkovich, probably I mispronounced his name, about how it's hard to refactor and how it can affect us. So, while waiting for our brightest ECS future and hoping that, okay, in next years there will be much more common situation, we still need to deal with our component-based design and with all these problems. So, let's talk about one thing here. Okay, let's try to create our component class just out of scratch. It would be a very basic one. We'd have this base class with constructor, with owner entity member, with constructor, with constructor and virtual destructor, with a couple of virtual methods on begin game update, and accessors to owners. Second, we need to specify entity, container for these components. So yeah, here we also have member represent an array, collection of these components, and we need a method for getting access to these particular components in such operations. It usually looks like this. So you iterate over this collection and then make dynamic cast of every collection to a required type which you're looking for. If it's not null pointer, you have a result. If it's not, you'll have null pointer. Is everyone familiar with dynamic casting? Yeah, so just few things how it's specified and started. The core idea that if you want downcast to represent a kind of parent object as a child object, there is a special instruction called dynamic casting, and it looks through child's objects, additional structures. We'll see about it a little bit later. And if it finds only one instance of a required class, it returns you a required pointer. If it finds either 0 or more than one instance, hey, hello to diamond problem, it returns null pointer. Yeah. So that is it. And let's try to make a very quick example from this. Let's say we have Krisha, which takes damage from lava. Well, he doesn't look like he takes damage, but let's assume this. And every time when it falls, it has this damage of 4.2. For this, first of all, we need health component, which will represent our current health state. And basic pieces of this component are member variable health and take damage method, which allows you just to decrease this health on a certain amount. Yeah, I know there should be a lot of additional checks, but let's keep it simple for example. And then let's say that we have some kind of component which detects collision, which can tell that we collided with a certain type of object by specifying, by checking some kind of special collision text which is provided by physical hardware, as Havoc usually. Yeah, and if we find that this is lava, we apply a certain amount of damage. So yeah, we get this component. If it's not null, let's take damage. Cool. Okay. Frankly speaking, this is not the way you need to apply damage in real games, and most of the time it's handled by such things as event system, but I was looking for some kind of example so for making it a little bit obvious, so let's stay with it. Don't do it in production code. However, sometimes you need to do such kind of hacks. Well, cool. The problem is that here, getting component is kind of expensive operation, and you don't know how much time you would need throughout the game to get this component. If this monster falls in the lava only once, or maybe throughout the game, or it will stay and just every tiki will have its own collision detected, and hey, it's gonna be insane. And this thing is actually really expensive. First of all, it iterates through the collection of components, and you don't know for sure, well, how many components do you have while applying to entities. If it works with one particular set of 2 or 3 components, fine. But if you try to apply this logic to another creature, it will have additional components. Maybe it's controllable, maybe it's not. So you would have unpredictable amount of interaction. But what is most important, it uses dynamic casting. Despite the fact that implementation of dynamic casting is not specified by standards and every compiler manufacturer can do it on its own, typical approach is following. In an instance of health component of a children class, you have pointer to virtual table, where pointers to all virtual methods are specified. And in this virtual table, you have pointers to type info, the runtime type information, which is provided by C++. In this type info, you have a collection of all base classes, and you need to iterate over them and just to compare every type. So it becomes also unpredictable on how many of these iterations you would make for checking this dynamic casting. And that's why dynamic casting, well, standard C++ dynamic casting is considered an operation which doesn't allow to have a constant type of comparison. Lots of articles on the internet, you can say why dynamic casting is better, and you have comparison for example, static casts amount in 1 second, for example, 200 million, and dynamic casting 21 million. Yeah. And another thing which is bad here is that we have at least 2, I guess, even 3 levels of indirection. And each indirection may involve cache miss. Does anyone familiar with cache misses? Okay, so for one who is not familiar, Here's current approach, well, very rough approach of how CPU works with memory. Usually, CPU gets data from cache memory, from data cache, which is the closest one, then puts it into the registers and processes it. This cache is populated from main memory, and time, complexity, performance cost for getting CPU access to L1 cache is maybe 1, 2, or 3 cycles, but for main memory, you need to do at least 200 or 300 cycles on modern architecture populated. And every time you have a pointer to some instruction, and CPU cannot find it inside the cache line, you need to flush it to have another set of data from memory, 200 more cycles, and this becomes really, really costly. Well, I think that we need to optimize it somehow. Okay, something that comes from the top of our head. Hey, if we need to work with this kind of often, not once, but several times throughout the game, let's save it somewhere, or in other words, let's cache it. Very straightforward approach. Let's use row pointer. We add a new member variable to our class, health component cache. It will be pointed to this component. In our begin game, we iterate over, we try to get this component from entity. Yeah, it's still expensive, but it happens at least only once. And when we detect collision, we check that it's not multiplier, and here we can just apply a damage. Wow, cool. We save time and only one level of indirection while working with this stuff. Problem is that it's okay if we are kind of convenient, if we are quite comfortable and sure that health component will have same lifetime as lever creature rigid body component. Yeah. If it will be removed for some reason, for example, if you just need to duplicate entity, okay, I need to remove this component, I don't need it at all, so I will make it immortal, or for some another reason. First time you will have this detection, there will be a dangle pointer, and you will have runtime crash. There's another issue with that. So while working with memory and allocating, deallocating, and placing objects, we usually have such thing as fragmentation problem, because the more memory gets populated, then it's get updated, the more these spaces between allocated data with empty type will exist. And one thing, well, in a situation when, for example, you have 4 gigs of available memory, you have 3 gigs of data only, and yeah, you need to allocate 1 more gig, for example, very huge array. But this data, 3 gigs of data, is split equally throughout the memory. You don't have a single piece of memory that just allows you to allocate this 1 gigabyte, and here becomes a problem. That's why modern game engines, and I guess every software system, sometimes have the fragmentation support. An operation which just looks in the memory, its segment, and say, okay, I need just to get this data from here and just move it here and make sure that I would have enough time. And if you have this fragmentation support on first run, this pointer also will become dangling and will have runtime crash. Well, it seems that we need something just to wrap it up and make it a little bit better. This thing, this thing is called smart pointer. Smart pointer is data structure which not only keeps pointer to the actual required data, but can store additional information and make decisions on actual creation or deletion of particular object type dependent on this information. This information would be something like reference counting. Okay, let's try to make something on our own. Yeah. First of all, we specify this structure. We add 2 members, which would be one would be a pointer to actual data, and what would be reference counter. Reference counter is a pretty simple class. It has counter, it has method of adding references, which increases this counter. It has method of releasing entity, releasing counter, which just decreases it and return an actual result. So in our class, we add constructors. Well, while creating from empty data of some particular already allocated, we just copy this data to our container and create reference counter and increasing it. But when we copy from smart pointer, create a new one from this, we not only copy data, but also copy reference counter and increasing it. While deleting smart pointer, we check it out. Okay, if reference counter, while after release, is equal 0, we can safely delete data and reference counter. Is it clear? Okay. So, moving next. Let's try to apply to our example. First of all, instead of collection of raw pointers, we have collection of smart pointers. We need to a little bit modify our get component method, and then inside this allow crucial body component would have also smart pointer to required component. We create it on begin play, and on start we use it and apply damage. Well, cool. We have here guarantee that it's not gonna be well, that at least this smart pointer exists. Health component will not be removed from entity, but it has two sides as every coin. It benefits us, but on the other hand, we are blocked from removing these health components unless we remove this component. And probably with one entity it's okay, but if you try to cache component from another entity, the whole entity won't be removed unless your entity is using it and have smart pointers for it. That's not good. It's a direct way to memory leaks and so on and so on. Yeah, so that's why usually we use such thing as hard reference and soft reference counting. So hard reference counting means that if you have at least one hard reference, you cannot remove this object. Soft reference counter just allows you to understand how many other classes, other objects using your own object, and just in case that data is already deleted, you can give them, okay, so it's deleted, it's null put error, so check it. Yeah, let's try to do it on our own. First of all, instead of reference counter, we would use additional data structure, which would be called data container, which would have not only these reference counters, but also pointer to required data. We modify, create constructors, add the structure, and which is checking if data is not empty, we need to remove it. Have methods for getting data, for adding hard reference and adding soft reference correspondingly, and for getting them. The thing is that when we remove hard reference, and if we check that it's equals to 0, well, yeah, typo, sorry, we delete data. Then we need to modify our smart pointer class and create a couple more. Well, since we store data inside this data container, we just keep the only member in the smart pointer and base class would be data container, and the method of getting data from this container. Every time we create container from scratch of some particular object, we create new data container. Copy constructor would be pretty straightforward. We just copy data container, pointer to data container into new class. But in the structure, if you have hard ref counting equals 0 and soft ref counting equals 0, you will delete this data container at all. This would prevent us from memory leaks and would make sure that, hey, we're okay with that, throw it away, we don't need it. This was the last smart pointer using our data, and we don't need just to exist anymore. And we had two children class. One will be, let's call it shared pointer, don't mix with C++. Shared pointer is kind of similar, but we're not using it. I will tell about why a little bit later, which increasing and decreasing hard reference counter and works with this. And weak pointer, which works with soft reference counting. So yeah, well, right now in entity, instead of storing smart pointer, we store shared pointer. Here code would be pretty the same. And in our creature rigid body component, we need to store only weak pointer. So when we try to get this component from our cache, from our smart pointer, and if all shared pointers are already deleted, we would have here null patterns, and we don't have any that kind of runtime crash, dangling borders, and so on and so on. So yeah, this is a thing that is used most of the time. But here's a drawback of this. First of all, as you mentioned, there would be one additional level of indirection here because you need to get pointer to the data container. From data container, you need to get pointer to the actual data. My colleagues told me that probably it would be somehow optimized. Maybe they're right, maybe they're wrong. And the other thing that right now, most game engines are multi-threaded. And in order to keep synchronization and to making data consistent, these member variables of data container will be atomic ones. So every time you create data container, despite the fact either it's shared pointer or weak pointer, you will have synchronization overhead here. And that's actually why it's not cool to use standard shared and weak pointers, because when you, for example, work with C++ weak pointer, as you know, you're locking it, creating shared pointer, which is released after its data was already required. And if you do this lock inside update loop, it will be very bad for performance. So, yeah, are we okay now? Actually not. As I mentioned, modern game engines are multi-threaded programs, and there could be such very strange situation. For example, when you got this component from your cache, and you need to do some additional actions here, but then you need just to do this take damage action. Somewhere here, another thread could remove it from thread, just could remove the shared pointer. We already saved pointer, and here it becomes dangling. We could either solve it by invoking every time, but getting this data every time we see this, we see necessity of using health component. But the problem would be that by adding this invocation call every time, we'll have these two indirections overhead. And that's not cool. And usually in local procedures, when you're working with some pointers which are got from other data structures, usually just cached in local variable and then work with this. So yeah, in this case, we would also have here runtime crash. Well, as I mentioned, one approach would be just to use to get data from smart pointer as much as you need to work with it. But another end, which is used most of the time, is that there is some particular place in the frame where all actual deletions are processed. It's after all updates, when you just need to check whether you can release resources or not, and then delete data. So in this case, we're becoming kind of safe of using these structures in our update code. Yeah, so probably you said, hey, you told us about defragmentation problem, how do you solve it here? So as soon as we have this custom data structure, we can add additional information while creating it to either to allocators or to other tables which would process it over time and check, okay, so we have this defragmentation task run, and we need to rearrange all smart pointers that we have in the system. Well, pretty cool. Finally, there's one more approach that, for example, either is an entity which is highly used by either is a component inside the entity which is highly used by other components. You need to have constant access to it, usually some kind of very generic like animation component, physical component, or skeleton component. It could be quite wise to save it inside entity, but instead of using different things as pointers, row pointers, smart pointers, you can just simply keep an index on it. And yeah, if anyone has ever read Jason Gregor's game engine architecture, he wrote about this approach of working with data, not exactly with particular stuff, but as an additional table, and instead of keeping smart pointers, just keeping an index to a special table, and it's called handles. So yeah, we add this health component index inside our entity class. Every time we update or modify a set of components inside our entity, we just run through iteration, find our actual component, and just assign proper index. Yeah, this is really costly. Luckily enough, it also shouldn't happen all the time, only when you modify this set. Yeah, and in our case, for just working with this health component, we can simply get from entity, well, also type, not skeleton, of course, health component, well, and apply damage to it. So pros, yeah, very small overhead, very simple. Things, cons that it couldn't be applied to every component in your game because otherwise your entity class would be overpopulated with stuff which is not generic at all. And also you still need to care about objects and components lifetime. So let's wrap it up. First, getting component from class is kind of expensive operation. Try to do it as rare as possible. It could still cost you really a lot. Second, it's kind of wise to save in indexes of mostly used game components inside your own entity, and you can use it very quick. You also should always be aware of component lifetime, well, just to make sure that you're deleted in the proper place and proper time. And if there is no defragmentation task, or you are kind of sure that component which you are using, working with, exists as long as you have your own component, which you are invoking it from, well, you can simply use raw components. It's pretty cheap. And finally, while working with smart pointers, just be aware that every time you create smart pointer, you add synchronization log. So also be careful not creating it for too often, only when you actually need it. So that's all from my side. Questions? Any
question? You mentioned in the talk about the synchronization costs of shared pointers. I was wondering, do you use a specific tool to measure that, or do you just use like a telemetry, or like how do you know that that's the specific thing that's a problem in your code in terms of performance? What tools do you use for that?
Good question. I guess this this would be mostly asked to engine designers. Yeah, it's profiled. Usually as gameplay programmer, we don't run such things. We usually read code. Okay, it's obvious that if you have any kind of synchronizations, there would be overhead. So, and if you do it in update, it's just common sense. But if you're interested in, I can contact my colleagues and we can discuss offline. Yeah, sure, no problem.
Hi, I'm kind of curious why you reinvented your own share pointer, weak pointer mechanism and promoting weak pointers to strong pointers and things like this. There's Boost, there's standard library stuff. What led you to
standard library?
Wheel?
Yeah, standard library, as I mentioned, when you use weak pointer, you just add lock, and by adding lock, you just create new share pointer for this lifetime. And if you add this share pointer, for example, in update method on a collision detected, so you will have this lock.
But you have to have that lock. That if you're using that mechanism, you have
well,
no choice.
in this one, no, because you have actual pointer to data, which is updated depending on how many reference counts you has. And here, when using it, well, you'll eventually have it while creating, but having it while using it, it's not that good.
I think okay, but every company I've been at, we always reinvent these things. The concepts that, like Boost, have a very solid shared pointer mechanism that you can plug in your own custom players. You can do all of this kind of work without reinventing all this kind of infrastructure. Like the core take-home from this seems to be the remove all necessary synchronization by doing deletes at the end of the frame, and then you have no concept of weak locks. You just have a share count, and when that count hits 1 at the end of the frame, you know you can lose it. What strategy do you actually practically use now in Studio? Are you using the shared pointer mechanism, or I'm just curious. Like, there's a lot of things you put up there, but I'm not sure.
Frankly speaking, there's because first of all, we are not invented this some kind of generic stuff from which we have dealt with, and it's most of the time it's provided by third party, by actually our customers. And while working with that, so as long as it's supported inside pipeline. We saw really very weird mixes of this stuff because, for example, it could be still raw pointers inside entity class, but still some processes that can, okay, so when I delete, I need just also check our share pointers. Weird, but that happens.
Okay,
so,
thank you.
Yeah.
Hi, I was just wondering if you could speak a bit more about moving from the kind of component-based world that you're talking about here to the futuristic data-driven world. And like, could you talk a bit more about the challenges involved about converting an existing game from one to the other, or?
It's mostly working with legacy kind of stuff. For example, if you made next part of well-known franchises, you already have a lot of data which using already existing code, and you don't want your project managers, your production team don't want to create it one more time. So you need to say, oh, okay, guys, we need 1 more year just to convert into ECS. And well, luckily enough, if you can prove them that, okay, so this would worth it, which would need just to make this full play test and QA iteration 1 more time with our code base, and we would lose 1 or 2 years in production on refactoring stuff. And well, yeah, it seems that it can benefit us, but there's no guarantee. So problem is time limitations and stability of things that already works. And if you do something from scratch, it's cool. Well, you can just use this approach. But if you're working with legacy stuff, you're kind of limited on timelines. And you should reuse already existing code and refactor it only it's really necessary.
More questions? Okay, thank you.
Okay,
I would like
for
to ask
attention.
you one more round of
One
applause.
note, yeah, we had some prizes for best questions, so guys, yeah. Here's for you. Yeah, okay. Yeah, that's all. Thank you.